Today we're looking at lesson 6.6, geometric sequence. Now, if you think back to before Christmas, we did arithmetic sequences. So that's why some of this is going to look familiar to you and some of it is going to be new. Before I go on to the next slide, I want to ask you a question. When we did arithmetic sequences, we had to find a common blank. Does anybody know what goes in that blank? Difference. We had to find a number that either added or subtracted across the list of numbers we were given would take us to the next number. Okay, that was the common difference. We found it, and then we were either adding or subtracting that number all the way across our list. All right, so if you look at the essential question for today, it says, how can you use a geometric sequence to describe a pattern? But before we get into any of that, we had a quick review. The arithmetic sequence has a common difference. And you find that common difference by doing what? You take the second term and you do what with the first term? Subtract. So fill in the blank. Okay? An arithmetic sequence has a common difference and it's found by subtracting the second term from the first term. Now the reason that's in here is because we're actually going to use that piece of information again in this lesson. So it's important that you remember that. Okay? But the new information for today is a geometric sequence. This is when the ratio, which we will call the common ratio, between each pair of consecutive terms is the same. So there is going to be a number that we are going to use across our list of numbers. And look at what we're going to do with it this time. Each term is found by multiplying the previous term by the common ratio. So this time, when we find that common ratio, we're going to take that number and we're going to multiply it all the way across our list. Now, look at example 1. It says, decide whether the sequence is arithmetic, geometric, or neither. And this is why you need to remember how to find the common difference. But you'll also see right underneath the example, I've given you how to find the common ratio because we haven't done that before. So take your highlighter and highlight common ratio. And look, you're still using the second term and the first term. But what are you doing? You're doing the second term divided by the first term. So this is new information. This is what I need you to highlight. Now, if you're looking at list A, let's make an educated guess about whether this is arithmetic or geometric. So think about what you know. All right? Look at the list of numbers. Does it appear as if they are adding or subtracting a number to it? Or does it appear as if they're multiplying a number by it? What do you guys think? If we took an educated guess looking at list A, what would you guys say? It looks like they're subtracting. The numbers are small. The numbers are close together. So I would say, before we try anything, let's try to find and test a common difference. Okay? So just like we did before Christmas, we're going to write down D equals and we're going to show our work. How, again, do we find the common difference? Second term minus the first term. Now, what is the second term in this list? 1. So 1 minus, what's the first term? 5. So what is the common difference? -4. Now remember, we're going to circle. We're not going to box because we don't know. That's not our final answer. But that is the number that we are going to test. So 5 minus 4 does give us 1. What about 1 minus 4? -3. So we keep going. -3 minus 4 gives us what? So, did the pattern work all the way across the list? So, this sequence is what? Arithmetic. Now, you'll notice in the directions it says at the end to explain. But just like last time, I will let your work be your explanation. So, I'm not going to look for a sentence explanation as long as you have shown me your work. But you showed me how you found the common difference. You showed me that you tested it all the way across. And you showed me why you got the final answer of arithmetic. All right, now let's move on to letter B. Again, let's make an educated guess. Could you just start and find the common difference every time? Absolutely. But why waste our time if we don't have to? Can you make an educated guess for me on letter B? Arithmetic or geometric? Based on the numbers and how far apart they are spaced. What do you think? Okay, geometric seems to be here. Now again, we can try geometric. If it doesn't work, we'll go back and try arithmetic. But I'm going to try geometric, which means I'm going to find the common ratio. All right, now this is new. look at what you highlighted. How are we going to find the common ratio? Give me the second term. 128 divided by the first term, which is 1024. Now keep in mind, you know me in decimals, okay? You can plug this in your calculator, but get me a decimal. Don't give me a decimal. Get me a fraction. What's 128 divided by 1024? 1/8. Now, it's the common ratio. So this is also new, but what are we supposed to do with that 1/8 all the way across our list? Look, we're supposed to multiply this number. If we have found a common ratio, we're going to take that number and we're going to multiply it all the way across our list. So 1024 times 1/8 will give us 128. So we keep going. What's 128 times 1/8? 16. And what's 16 times 1/8? 2. Okay, so if the pattern works all the way across, we multiplied all the way across by 1/8 and it worked. So what kind of sequence is this? Geometric. Again, your explanation is your work. You showed me that how you found the common ratio, and then you showed me that you tried it all the way across. Now look at letter C. All right, we can try to make an educated guess. We've got a 2, a 6, a 10, and a 16. So what do you think on this one? Arithmetic or geometric? All right, let's start with arithmetic. That one makes sense. The numbers are smaller. They're closer together. So let's try a common difference. All right, how do we find the common difference for this one? 6 minus 2. So the common difference is equal to 4. All right, so let's test it. 2, of course, 2 plus 4 is going to give us 6. What's 6 plus 4? 10. What's 10 plus 4?
14.
So that doesn't work. So we cross it out, which means now we got to find a common ratio. How do I find the common ratio? 6 divided by 2, which gives me a common ratio of 3. All right, and what are we supposed to do with the 3? Multiply it. So 2 times 3 is 6. What is 6 times 3?
18.
Does that give us the next number we needed? No. So if the common difference doesn't work and the common ratio doesn't work, then what situation do we have here?
Neither.
This is a neither situation. Now look, I get it. Some of you are smart enough to look at that and figure out pretty quick that it's a neither situation, and that's awesome, but I still need you to show me work. All right? Because I don't want you in the habit of just guessing. I want you in the habit of proving to me why your answer is neither. Moving on to example 2. It says, write the next 3 terms of the geometric sequence. Now listen, it's telling us that it's a geometric sequence. So when we find the common ratio, there's no need for us to test it to prove it's geometric. Okay? You can test it to make sure you got the right common ratio, but we already know it's a geometric sequence because it told us. So what we need to do is we just need to find that common ratio and we need to apply it and find the next 3 numbers. All right? So look at letter A. We've got 1, 3, 9, and 27. So how do we find the common ratio? Michael, for this problem, how are we going to find the common ratio? 3 divided by 1, which is going to give me a common ratio of what? 3. Awesome. Now, circle, don't box is not our final answer, but we do need it to stick out to us because what are we supposed to do with the common ratio? Multiply. So here's all I need to see. If you show me that you, from the last number, the 27, you are going to multiply by 3, that shows me that you know what to do with the common ratio. So now all I need is the next 3 numbers. So what's 27 times 3? 81. What's 81 times 3? 243. And what's 243 times 3? 729? Is that what y'all said? Yes. Good. So you showed me how you found the common ratio. You showed me that you knew what to do with it. And then you gave me the next 3 numbers. That's all I'm looking for. Now looking at letter B, we start by finding the common ratio. How are we finding the common ratio for letter B? Negative 40 divided by 80. Now you, again, don't give me a decimal answer. All right, give me a fraction. What is negative 40 divided by 80? Negative 1/2. And again, what are we supposed to do with that negative 1/2? We're supposed to multiply. So we're going to show that we know to multiply by negative 1/2. Now, what is negative 10 times negative 1/2?
-5.
Not negative, because you're doing a negative times a negative, which gives you a positive. Okay, so it's a positive 5. Now, give me fractions and you can keep them improper. All right, I don't want decimal answers here and I don't need mixed numbers. So you continue finding the next two numbers, but give me fraction answers. So what is 5 times negative 1/2? But give me improper. Negative 5 over 2. All right, what's negative 5 over 2 times negative 1/2? 5/4. Now listen, you should be able to do this without a calculator. Let me remind you of a couple of things. All right, first of all, look at the pattern. 80 was positive, 40 was negative, 20 was positive, 10 was negative. So that pattern of signs should continue. It's a positive 5, then a negative 5/2, then a positive 5/4. Okay, but you don't need a calculator to multiply fractions. Remember, you just multiply the numerators, multiply the denominators, and move on with your life. So the calculator really shouldn't be necessary as long as you remember that. Okay? Before we move into example 3, we need to be able to break apart this formula. This again should look familiar to you because we did the same type of thing with an arithmetic sequence. We wrote an equation for an arithmetic sequence. Now I realize this formula is new, so a couple of things. First of all, I want you to highlight the formula. Second of all, if on your paper the a sub 1 and the r are a little bit, I think they're attached somehow, you can rewrite that formula if you need to. But it's a sub n equals a sub 1 times r raised to the power of n minus 1. Now, how do I know it's multiplication? Because what is between a sub 1 and r? Nothing. Okay? So when you have two variables that have nothing between them, that's multiplication. So a sub n equals a sub 1 times r to the power of n minus 1. Now, a sub n should look familiar to you. Remember, a sub n is the term that we are looking for. So if they have not given us a number, they've given us the letter n, that means this equation will work for any term that they were to give us. Okay? A sub 1 is the value of the first term. I mean, guys, the first number in the list is a sub 1. N is the position number. So again, once we have the equation, they may ask us to find the 18th term. Well, that's where the n would come into play. We would replace n with the number 18 because that's the position of the number they want us to find. And then last, r, again, is the common ratio. So there is a second place now in your notes where I have given you how to find the common ratio. Now look at example 3. It wants us to do two things. Write an equation for the nth term of the geometric sequence, then find a sub 7. So we got to write the equation first. Now, it's real simple. To write the equation, you find and plug in, and I would highlight this, a sub 1 and r. So we're going to find the first term, we're going to find the common ratio, and we're going to plug them into that formula that we just highlighted. So let's start by identifying a sub 1 because that's the easiest thing that we're going to do today. What is a sub 1 in letter A? 1. The first term in the list is a 1, so a sub 1 is 1. Then we're going to find and identify the common ratio. So we'll do the work over to the side, and then we'll transfer our answer. Riley, how do we find the common ratio? Take negative 5, and we're going to divide it by 1. So what does that make the common ratio? Negative 5. Now, we're going to write the formula down because we don't know it yet. And so the more we write it down, hopefully the easier it is to memorize. So let's write the formula down. It's a sub n equals a sub 1 times r raised to the power of n minus 1. Now, we have those two pieces of information, so we're going to plug them in. A sub n equals, what is a sub 1? 1. Now, I'm going to plug, and you're going to plug the r in parentheses every single time. That's how we're going to remember that we're multiplying and that it's not, in this case, 1 minus 5. So we are plugging r in, which is negative 5. We're going to plug it into the problem in parentheses. And then, of course, we're raising it to the power of n minus 1. Now, if you think back to the arithmetic sequence, we were able to distribute the common difference and combine like terms before we were done with the problem. So my question for you is there anything we can do here to simplify this equation further before we box it in? It says that we can multiply 1 times negative 5. Now, that would be the case except for, please excuse my dear Aunt Sally. The order of operation tells us that we are supposed to do what first? Exponents. Okay? Yes, technically parentheses, but there's no work in the parentheses to do. So we move to excuse, which is exponents. Then my stands for multiply. So I cannot multiply unless I'm able to do the work with the exponents first. And because this is n minus 1, I cannot do anything to the exponent at this point, which means this is as far as I can go. So a geometric sequence has a little bit less work on this part. All you can do is plug in the a sub 1, plug in the r, and box in your answer. This is the equation that would help us find any term we wanted in this list. Now, what term have they asked us to find, though? A sub 7. So right underneath the equation, we are going to write a sub 7. Now, they replaced n with what number? 7. So that means when we work the problem, we're going to replace the n in the problem with a what? 7. Okay? So obviously we got to figure that out first. What is 7 minus 1? 6. Now, at this point, here's what I'm going to allow you to do. At this point, let's just plug all the work into the calculator and get the final answer. Just make sure you're doing the right work in the right order. What are we supposed to do first in this problem? According to, please excuse my dear Aunt Sally, we got to do the exponent before we can do the multiplying. Now, be very careful in your calculator and make sure that is a negative 5, so it needs to go into the calculator inside a parentheses, or it will not come out with a correct answer. So negative 5 raised to the power of 6, and then what is the last thing we're supposed to do? Once we have the power worked out, we're supposed to do what? Multiply by 1. And what does that give us as a final answer? 15,625. So that is the second answer that we are boxing in. For letter B, again, we have to identify a sub 1 and we have to identify the r. So very quickly, you should be able to tell me what is a sub 1 for this problem. 432. And of course, over here to the side, we'll find the common ratio. How do we find the common ratio? 72 divided by 432. And what fraction? Remember, we want a fraction. What does that give us? 1/6. Okay? So we're going to transfer that. And really, once you have that answer, you can just transfer it right over here. Now, let's write down the formula. Again, until we have it memorized, we're going to keep writing it down. A sub n equals a sub 1 times r to the power of n minus 1. What goes in place of a sub 1? 432. All right, Haley, what goes in place of r? 1/6. And remember, we plug it in parentheses, and then we raise it to the power of n minus 1. Are we able, Jeremiah, to go any further on this problem? No, okay? We cannot do anything with the exponents yet, so we can't do anything else. We stop and we box in the equation. Now, again, they've asked us to find a sub 7. So what are we plugging in place of n in our problem?
7.
A 7. And again, what is 7 minus 1? 6. So we have 432 times 1/6 raised to the power of 6. Now again, from this point, just do all your work in the calculator. Do it in the right order though. So in parentheses, I'm plugging in 1/6. I'm raising that to the power of 6. And yes, it's going to give me a decimal, but that's okay. Keep going. What are you supposed to do once you have done 1/6 to the 6th power? What's the very last step? Multiply by 432, and when we do that, what do we get as our answer? A sub 7 equals what? 1/108 is your final answer. And that is lesson 6.6.